This module was designed to help you deepen your understanding of subtraction strategies as seen in the course. For a specific strategy, you can find base 10 language at 27 seconds, decomposing at 5 minutes, keep the distance at 9:52, number between 14:27, negative numbers at 17 minutes, and then some practice problems at 19:47. Using base 10 language is all about the intentionality of using the place value units when you are subtracting. It not only helps when subtracting, but also sets us up to be able to multiply and divide using base 10 language as well. With the problem 654 subtracting 320, I'm going to be intentional about using the correct unit when subtracting. So 4 ones minus 0 ones would give us 4 ones. Looking at the tens place, I have 5 tens, and I'm subtracting 2 tens, which leaves me 3 tens. And in the hundreds place, I have 6 hundreds, and I'm subtracting 3 of them, which leaves me with 3 hundreds. In this example, I'm going to use the different form of 174 and 141 to subtract. So 4 ones subtracting 1 1 leaves me with 3 ones. Now I'm going to look at this as a group. So instead of talking about 7 tens and 100, I'm going to look at it as 17 tens subtracting 14 tens, which leaves me 3 tens, for a difference of 33. Here's another example of that kind of thinking. Looking at these two numbers, I can start with 8 ones and subtract 5 ones, which gives me 3 ones. Then again, looking at this as a group of tens, instead of having 0 tens and 4 hundreds, I can say 40 tens subtracting 20 tens to give me 20 tens, and a difference of 203. In this example, I'm going to use the idea of the base 10 language to help eliminate some of the unnecessary steps for the standard algorithm. So taking a look at 503 and subtracting 219, I'm going to look at this as two separate groups, ones and tens. So looking at this part, 3 subtracting 9. In order to have enough to subtract 9, I'm going to go over and take 1 away from the 50 tens that I have, and what I'm left with is 49 tens. Then I'll take that 10 that I decomposed and turn it into 13 ones. Now I can go ahead and subtract the ones, giving me 4 ones, the tens, giving me 8 tens, and finally the hundreds, leaving me with 2 hundreds. Here's one for you to practice, so why don't you pause the video and give this one a shot using the base 10 language. Restart the video when you are ready. There are different ways to look at this problem when using the base 10 language. We could say that we have 4 ones subtracting 2 ones, 7 tens subtracting 6 tens, and 100 subtracting 0 hundreds. We can also look at it as 4 ones subtracting 2 ones, and 17 tens subtracting 6 tens. Grouping it in a different way, we could also say that we have 74 ones subtracting 62 ones, and then 100 subtracting 0 hundreds. Here's another one that gives you a little bit different look at using the base 10 language when regrouping. Again, pause the video and give it a shot, and then restart the video when you're ready. Again, for this problem, there are different variations that we could use. We could look at having to regroup with the 1 subtracting 5. So we could look at 35 tens, and if we take one of those tens, it becomes 34 tens and 11 ones, and then subtract. You could also look at this as 51 ones subtracting 5 ones, and then 300 subtracting 100. The strategy of decomposing numbers can be a great one to use when we want to make larger numbers a little smaller and easier to manage. Using the problem 16 subtract 9, I'm going to use a different form of 16. And in this case, I'll use the expanded form, so 10 and 6, to make the same value of 16. And that makes it really nice because looking at the 9 that I have to subtract, it would be really easy to take 9 away from that 10. So looking at 9 as a value of 9 and no more, using the different forms of these numbers can help me to be more flexible. So looking at 6 subtract 0 leaves me with 6, and then 10 subtract 9 leaves me with 1. Be careful not to confuse this with 16, because it's not a 10 and a 6, it's 1 and 6 more. If we look at this using the concrete quantity, we can see that if we have 10 and 6 more, and then we work on our subtraction, we look at 6 subtracting 0, which leaves us with that value of 6. We take nothing away from it. And then looking at the 10 and subtracting 9, if we take 9 from that 10, what it really leaves us with is 1. Now we can see where the 1 is left from subtracting the 10 and the 6 others combine to make a difference of 7. So using the same problem, let's take a look at it in a different way. This time I'm going to decompose both the minuend and the subtrahend. 16 will become 10 plus 5 plus 1, and 9 will become 5 plus 4 plus 0. 1 subtract 0 is 1, 5 subtract 4 is 1, and 10 subtract 5 is 5. Once again, we can show it in physical quantity as well. So here's our 10, our 5, and our 1 more. Now if we subtract our 5 from the 10 that we have, that leaves us with 5. Now we can look at the other 5 and subtract 4 from it. So removing 4 from this 5 leaves us with 1. And then finally our 1 that we need to subtract nothing from remains a 1. So here again you can see the 5, the 1, and the 1 for a difference of 7. So here's another problem that I started, and I decided to break it down into the base 10 or expanded form, and started to see that 3 minus 0 is easy, but I'm not too sure if I like the 20 subtracting 9. So watch how I rethink this with a little more flexibility. 23 will become 10 plus 10 plus 3, and 9 will become 9 plus 0 plus 0. By using a different form of 23, I have made the subtraction more manageable, and I can still find that the difference between 23 and 9 is 14. Why don't you pause the video here and see if you can try this one? I decided to start by breaking these numbers up into the expanded form, and then realized that I wasn't going to like 3 subtracting 5. So instead I put 33 as 10 plus 10 plus 10 plus 3, and 15 as 10 plus 5 plus 0 plus 0. Subtracting 3 and 0 you get 3, 10 minus 0 is 10, 10 minus 5 is 5, and 10 minus 10 is 0 for a total of 18 as my difference. Here's another problem for you to try, this one with a little bit larger numbers. So go ahead and pause the video, give it a shot, and then come on back, and you can see how your solution is similar or different to mine. For this one I decided to use the expanded form, so 100 plus 40 plus 1, and then 90 plus 6 plus 0. I then decided to subtract from left to right, so 100 subtract 90 is 10, 40 subtract 6 is 34, and 1 subtract 0 is 1, for a difference of 45. When we're talking about keeping the distance, we're talking about finding the difference between the two numbers that we're subtracting. And finding the difference is actually finding how far apart these two numbers are on the number line. With this problem, we're showing the distance between 16 and 9 on the number line. Working with numbers that are close on the number line makes it easy to stay in one's world and count each increment. As we get to larger numbers, it won't be efficient to use this method. By developing the strategy of keep the distance, you're allowing yourself to become more flexible with larger numbers and finding the distance between them on the number line. And realizing that 9 is close to 10 and I just have to move 1 up on the number line to reach it, I'm going to do that. And in order to keep the distance, I also need to move 1 up from my minuend. So now instead of working with 16 and 9, I am working with 17 and subtracting 10. The distance remains the same, and now I have easier numbers to work with mentally. Here's another example where we're looking at the difference between 26 and 8. So thinking about this, wouldn't it be nice if the 8 were moved to the 10, because it would make it much easier mentally to calculate. And of course, if we move the 8 to the 10, we're moving up the number line 2. So we must keep the distance and make sure we move up the number line 2 with 26 as well. So now instead of working with 26 subtracting 8, we will be looking at 28 subtracting 10, or the difference between 28 and 10. So let's take a look at what this looks like with larger numbers. So in the example of 91 subtract 67, we are looking for the distance between 67 and 91. These are tough numbers to work with mentally. So wouldn't it be nice if we could just bump that 67 up to 70, make it a nice round 10? In order to do that, we have to move 3 spots up the number line. And in order to keep the distance, we also have to move 3 spots up from 91. So now, instead of working with 91 subtract 67, we are working with 94 subtract 70. I love to use this strategy when looking at subtracting across zeros because I am not one that likes to do all the steps for the standard algorithm. It gets tedious. So what if instead we decided to use the keep the distance method to remove all necessity of having to decompose hundreds and tens? So what if we moved the 500 down the number line by 1 spot? And then in order to keep the distance, we move our subtrahend down by 1. So now we're working with 499 and subtracting 297. This eliminates all reason for regrouping and makes the mental calculations much easier. Let's take a look at this problem in a different way. So instead of moving the 500 down to 499, I could also move 298 up to 300. And of course I went up 2 from 298, so I must also go up 2 from 500 in order to keep the distance. And again, we have a much easier mental calculation to work with. Here are 2 practice problems for you to try. And depending on your preference, you can move either the minuend or the subtrahend to make it an easier number to work with mentally. Just make sure that both quantities are moved the same amount in order to keep the distance. The number between strategy is similar to keeping the distance in the sense that we want to make the numbers we're working with easier mentally. The difference in the strategies is that with the number between, we are going to find a nice number as our kind of stopping point in between the 2 numbers to make a nice, easy mental transition. So we're still looking for the distance between 17 and 33. But this time, I'm going to start at 17 and take a little walk to get to 20, which is going to be my number in between. That's easy mental math. 17 to 20 would be 3. And then from 20 to 33, I can also compute that mentally with 13. And then all I have to do is think about those two jumps that I took together for the whole distance, and I can see that my distance is 16. It is not uncommon to want to stop and break it up into more than just 2 jumps. So if you need to see it broken down a little bit further into more than one number in between, you can also use that open number line concept to get yourself from 17 to 33, just with a few more stops on the way. Here's another example. So this time my number in between is going to be 30. So from 41 to 30 is a change of 11, and then from 30 to 28 it would be a change of 2. So looking at those 2 steps that I took, 11 and 2, would tell me that my total distance or difference between 41 and 28 is 13. Here's another problem, and why don't you pause the video and try this one yourself, and then come back and see how I solve it and compare the 2 strategies. So I chose my number as 100 in between. So 116 to 100 is 16, and 78 to 100 is 22, putting that together for a difference of 38. Here's another one to try for practice. So our last strategy is using negatives, and I am also going to rely on my base 10 language to make sure that I'm notating things properly. So looking at the problem 25 subtract 16, I'm going to ask myself, what is 5 subtract 6? And allow myself to go into the negatives, so that would give me -1. And then looking at the tens, I have 2 tens subtract 1 10, which leaves me with 1 10. And then all I have to do is combine those 2 values, 10 and a -1, and I would see that my difference is 9. So here's another example, 42 subtract 17. So I would ask myself, what is 2 subtract 7, which gives me a -5. And then moving into the tens place, I have 4 tens subtracting 1 10, which leaves me with 30. Combine those 2 values to get a difference of 25. So here's a different look. What happens when the negative is in the tens place? So 457 subtract 184. We'll start in the ones place. So I have 7 subtracting 4, which leaves me with a positive 3 ones. And then moving into the tens, I have 5 tens subtracting 8 tens, which really is a -3 tens or a -30. And then finally 400 subtracting 100 leaves me with a positive 300. Then combining those values, we have 300 plus a -30, which would give us 270. Add that to our 3 ones, and we have the difference of 273. Here's one for you to try. So pause the video and go ahead and work through it yourself using negatives, and then come on back and you can watch how I solve it. So I'm going to start in the hundreds place and go 200 subtract 100 gives me 100. And then moving to the tens, I have 2 tens subtracting 1 10, which gives me 110. And finally the ones, I have 4 subtracting 9, which puts me in the negative by 5. Adding those together, I have 100 plus 10, which gives me 110, plus the -5 or subtracting 5 gives me 105 as my difference. Here are some general practice problems for you to try. I would suggest trying each of the different strategies to see which one works best with the different scenarios, and that way you have some practice with all of them. It's a great way to practice that flexibility of problem solving. Thanks for taking the time to watch this module and improve your understanding of subtraction strategies. If you have any questions, feel free to email info@altshift.education.